Let's explore these chi-square tests or applications of chi-square tests in detail in forthcoming slide. So, types of chi-square tests. There are several types of chi-square tests, each designed to analyze different aspects of categorical data. So, the main types of chi-square tests include chi-square test of independence, chi-square test of goodness fit, chi-square test of homogeneity, and Fischer's exact test. And we will begin with the chi-square test of independence, and we will understand that in detail. So, chi-square test of independence is a statistical test used to determine whether there is a significant association or independence between two categorical variables. So it assesses whether the observed frequencies in a contingency table are different from what would be expected if the variables were independent. So then how do we define the chi-square test of independence? The chi-square test of independence evaluates the relationship between two categorical variables to determine if changes in one variable are related to changes in other variable. So to which all where it is applicable. So applicable to the chi-square test of independence is applicable to data with two or more categorical variables. It analyzes the association or independence between these variables. So the formula, as we have seen before in our previous slides, the chi-square statistic for independence is calculated using this formula, which is chi-square is equal to summation of uh, a deviation of O sub I minus E sub I whole square divided by E sub I. So where O sub I represents the observed frequency in each cell of the contingency table, and E sub I represents the expected frequency under the assumption of independence. Okay, then let's see some real life examples. So first one, research on the association between smoking habits. Obviously, smoking habits is a categorical variable whether you are a smoker or non-smoker, and lung cancer diagnosis. So it's also categorical, diagnosed or not diagnosed in a population. And analyzing survey data to determine if there is a relationship between gender. Again, it's a categorical, male or female, and we have non-binary genders, also many more, and preference for a specific product. It's also if you want to go with the product or not, yes or no, a binary or binomial or dichotomous. And the third example that we have for chi-square test of independence, where the chi-square test of independence can be applicable, is investigating whether there is a significant association between education level. Basically, education level is categorical: high school, college, graduate, and employment status. Again, categorical: employed, unemployed, self-employed in a particular region. So in these examples, the chi-square test of independence would help determine if there is evidence of an association or independence between variables of interest, providing insights into potential relationships and dependencies in the data. So this is what is a chi-square test of independence. So what we have next is chi-square test of goodness of fit. So chi-square test of goodness of fit is a statistical test used to determine whether observed categorical data fits a specific theoretical distribution or expected frequencies. It compares the observed frequencies with the expected frequencies based on a hypothesized distribution. So, how do we define this? The chi-square test of goodness of fit assesses whether the observed frequencies in a categorical data set differ significantly from the expected frequencies under a specified distribution or theoretical model. So it's applicable to the chi-square. The chi-square test of goodness of fit is applicable to data with a single categorical variable and assesses whether the observed frequencies deviate significantly from the expected frequencies based on a specified distribution or a model. And formula, by and large, it's same chi-square and sum of squares of O sub I minus E sub I all divided by E sub I. And we got the real life examples where the chi-square test of goodness of fit can be used. The first one, testing whether the observed distribution of blood types A, B, it's obviously multinomial variable in a population follows the expected distribution based on the Hardy-Weinberg equilibrium. And second example that we have here is assessing whether the observed frequencies of eye color. Eye color again, it's a blue, green, brown. It's a multinomial. In a sample match the expected frequencies based on a population study. And evaluating whether the third example, evaluating whether the observed distribution of responses agree, neutral, disagree in a survey matches the expected distribution based on a hypothesis about people's preferences. In these examples, the chi-square test of goodness of fit would help determine whether the observed frequencies deviate significantly from the expected frequencies, indicating a potential discrepancy between the observed data and the specified distribution or model. So now let's look into the third type of chi-square test, which is chi-square test for homogeneity. So the chi-square test for homogeneity is a statistical test used to determine whether the proportions or distributions of categorical variables are the same across multiple groups or populations. It assesses whether there is evidence of heterogeneity or differences in the distribution. So how do we define that? The chi-square test for homogeneity compares the observed frequencies or proportions of categorical variables across different groups or populations to determine if there are significant differences among them. So where it's applicable, so it's applicable to, so the chi-square test for Homogeneity is applicable to data with multiple samples or groups. So it compares the distribution or proportions of categorical variables across these groups to assess homogeneity or heterogeneity. So the formula remains same by and large. So let's see some of the real life examples for this. And one is comparing the political party preference. Example BJP or Congress or Aam Aadmi Party among different age groups. Example 18, 25, 26, 41, 41, 60, and 61 plus. So this is the best example and it's widely used. So comparing the political party preference among the different age groups. And second one, analyzing the distribution of hair color, blondie, brunette, redhead across different ethnicities. Uh, Example, Caucasian, African American, Asian. And the third one, investigating whether the proportions of customer satisfaction ratings, example, satisfied, neutral, dissatisfied, differ significantly across different branches of a retail chain. The fourth or the next type of test that we have here is Fisher's exact test. Fisher's exact test is a statistical test used to determine the association or independence between two categorical variables in a contingency table. It's particularly useful when dealing with small sample sizes or when the assumptions of the other tests such as the chi-square test are violated. So Fisher's exact test is a non-parametric statistical test that calculates the exact probability of observing a particular distribution of frequencies in a contingency table under the null hypothesis of independence. And it's applicable, the Fisher's exact test is applicable to data with a single contingency table that contains two categorical variables. It's used to determine if there is a significant association or independence between these variables. So how do we calculate that? Uh, Here for the Fisher's calculation, the calculation of Fisher's exact test involves evaluating the hypergeometric probability distribution for all possible distributions of frequencies in the contingency table. So the exact formula is complex and involves combinatorial calculations we can use directly from the softwares. So real life examples, analyzing the relationship between smoking status, smoker, non-smoker, and development of lung cancer in a small sample of individuals, and investigating the association between gender, male, female, and job satisfaction level, satisfied or dissatisfied in a small workforce. Everything, if it is small, this can be applicable exactly. That's why it's a Fisher's exact test. And assessing the link between the use of a specific medication, yes, no, and the occurrence of adverse side effects present absent in a clinical trial with a limited number of participants. So in these examples, Fisher's exact test would provide insights into whether there is a statistically significant association or independence between the two categorical variables, taking into account the sample sizes and distributions observed in a contingency table. So now the most important question arises. So these are the types of chi-square test we have, but which chi-square test is widely used by data scientists for data science to find out the statistical significance of the relationship between categorical dependent variables and independent variables. That's what is important for us. That's what is point of interest, so that we can use the respective test. So that's the reason I haven't gone through the other tests which are not required in detail. So whichever is required for data scientist, that we will be dealing in detail. So in data science, the chi-square test of independence is widely used to find the statistical significance of the relationship between categorical dependent variables and independent variables. This test is used when we want to determine if there is a significant association or dependency between two categorical variables. So the chi-square test of independence assesses whether the observed frequencies in a contingency table differ significantly from the expected frequencies under the assumption of independence. It compares the observed counts in each cell of the table with expected counts calculated based on the assumption of independence between the variables. So the chi-square test of independence is widely used in various fields of data science, including market research, social sciences, healthcare, and customer behavior analysis, to examine the relationship between categorical variables and gain insights into their associations.